joining us today. Our team name is GeoDudes. Our project is a standalone vision learning smartphone application. Our team consists of Madison Lafbon, our team leader and requirements analyst, Timothy Kafoman, our technical writer and software architect, Ben Tron, our software architect and software designer, and myself, Marnell Del Rosario, lead database specialist and requirements analyst. Our advisor is Dr. Boris Govolchuk, and our client is an assistant professor of the geology department, Dr. Ann Egger. The content of this presentation will include the introduction and the project overview discussed by me, program design presented by Tim, debug and testing by Vin, and demonstration and the report by Madison. The real-world problem for our project is that the current application lacks interactive features which normally would appeal users. In addition, the targeted audience is quite small because the current application only exists in the iOS for the iOS platform. The proposed solution was to redesign, expand, and improve the existing application. This means to develop for the Android platform using a different programming language and add features to the current version. We feel that completing the smartphone application will attract more users and expand our targeted audience. Displayed in front of you are the major components involved in our project. We thought that this would be useful to show a broad overview of our project, explaining how we work with our client and a third-party company called Vision Learning. As you can see, the current glossary on the right side, the current glossary was initially developed by Vision Learning, designed specifically for the iOS platform, and the database is owned by our client. On the left are the components that our team utilizes in developing the Android version of this application. Now for a short recap from our last presentation, we are developing for both the Android platform and the iOS using Java, XML, and Objective-C. For the Android version, Java is used for the activities and functions, while XML is mainly used for the layouts and the user interface designs. Objective-C is used for the iOS version of the application. As for the IDE, we are using Xcode, or as for the IDE, we are using Eclipse with Android development tools and Xcode for the iOS. The database software, the database is provided to us by our client. It's an SQLite database consisting of terms, definitions, and modules, and images. Next, Tim will discuss the iterations and our program design.
Our team follows an agile development process, and as a result, we have a total of 4 iterations throughout the project. The first iteration was completed at the end of the last quarter with a working prototype. The prototype was similar to that of the existing application. After the first iteration, users were able to access articles in the Vision Learning website using modules included in the database. Furthermore, the prototype was able to display images, definitions, and randomly display terms from the database. During the second iteration, we developed the flashcard portion of the application, which was in fact our client's top priority. We also designed a new interface and developed the search function. For the third iteration, we finished the Android flashcard application and are in the process of completing the iOS version. We started working on the client's second priority, the crossword portion as well. In addition, we're including a feature to add terms to the database. Finally, the fourth iteration consists of creating a toggle to change language settings for the user interface. We're going to be including the Spanish language. We will then polish and prepare our application for publication. This diagram shows an overview of our iterations and how each class uses layouts and shows how they are connected to our database. The green boxes indicate the layout, the red boxes indicate the database, and the black boxes represent the classes and activities. The first two iterations show what we have completed so far. We will now discuss our program design. We use the Model View Presenter design in our project. The Model View Presenter is a derivative of the Model View Controller software pattern. In the Model View Presenter, the presenter assumes the functionality of the middleman, played by the controller in the Model View Controller. The view is responsible for handling the user interface events, like clicking a button, for instance. There are three main components. The model includes the database and all the entities and data for the user application. In our case, our client uses an SQLite database. The view represents the application's user interface. The presenter manages the logical operations that update the model and view as shown in the following diagram. The Model View Presenter separates the data held by the model from the view, linking them for the presenter. So the question is, why are we using the Model View Presenter and not the Model View Controller? And the key difference between developing for a mobile platform and a desktop application is the size of the screen. Since the interface is limited to the size of the screen, we have to make different views to match user interactions with the application. This leads to different presenters for each view. In the Android platform, these presenters appear as activities. In terms of the view, we are using XML layouts to construct the interface. Vin will now discuss debugging and testing.
So, like any other development team, we also encounter with a lot of problems throughout the making of the application. And mostly the problem arrive from the conflicting Android version. As you know, there are different versions of Android out there, but not on the phone can install the newer version of the Android. So we're trying to cover as much as possible. We have to work on the Android version, which have different libraries sometimes, and sometimes when we're trying to get to the newer version, there are obsolete class and methods that's not supposed to be used anymore. And so the resolution for the fixing bugs, we try to fix those bugs as soon as they arise. And luckily, they are mostly minor bugs. For example, like typo in queries, and they memory leak because they're not closing the database after we use. For testing, we conduct both white box testing and black box testing. For white box testing, we use the Android extension of the GeoDudes provided by Google for unit testing. For GUI testing, we utilize the hierarchy viewer and the layout of tools that included in the Android SDK. I will show these tools in the next slides. For black box testing, we install an application on several Android devices of our friends and co-workers, and have them try out the application and give us feedback on a predefined form that we give them. To test the GUI, we using the hierarchy viewer provided from Google. This is a powerful tool that help us to analyze the layout of the application. So you can see there's the hierarchy of our layout, and it's also shown the position of the view and the element of the layout at the right corner right there. More importantly, it also shows the speed and how fast the phone actually lay out, measure, and draw the view. The green dot indicate that the application draw the view fast, and the red one is slow. But it show red dot means slow. It actually only happened in around 30 milliseconds, which is pretty fast for normal eyes. So we hope to take a look at those red dot and try to make it better in the future. The other tool that we use to improving the user interface, the layout, just a command line tool that actually analyze the XML layout files and give suggestions on how to improve the current layout that we are using. So with the client, we conduct acceptance testing. This is completed before the end of each iteration, and we give the application a device that with a pre-installed application to test, and we also provide her with a form to collect feedback and comments and any requirement that she wishes to change in the next iterations. And coming up next, we will present the demonstration of the application.
Okay, so starting our application, we are presented with a new layout that we designed for this iteration and future iterations. Currently, only the flashcard and the index buttons are implemented. Later, as has been said, the rest of the buttons will have functionality. Going into the flashcard feature, we're presented with a list of terms that are currently in the database. You can scroll through them, select the words that you would like to quiz yourself on. As you're selecting them, the program or the list lets you know that you're adding terms to your flashcard list. Once you're satisfied with your list, you can click the Add button, which takes those terms over and presents you with a kind of a basic flashcard layout. We're first presented with the term, and upon quizzing yourself on it, or feeling comfortable with it, you can flip the card over and present you with the definition. Presented at the top of the screen is just position in the list that you're currently on and the amount of the terms that are in your list. If you feel comfortable with the term, you can hit the check button, which takes it out of the current list and puts it into another list to either be erased or repopulated in that list if you wish. The X button just means basically the exact opposite. If you're not comfortable with it, it keeps it in the list and then will stay there for you to quiz yourself later. And as you're clicking the list, is the randomly generated or randomly showing you the words from your list on the flashcard. As we get to the end, we are prompted with two options. You can either view your results or review the flashcards. Going into the results, we're presented with a tab pane. In the check tab, it's just, like I said, the terms that you have recently put, just checked, the terms you feel comfortable with, and the X is all the other terms. Another feature that we've implemented in this iteration is we've utilized a settings feature that is standard on most Android phones. On the bottom, when we click the little button down here, we're presented with two options. We can either restart the flashcard or return to our main interface. Another feature that we've implemented is the search feature, which is another standard button on Android platforms. Clicking the search feature, we're presented with a text field in which we can type either a word or just a couple of letters, and we will be presented with all the words in the database that correspond to those, that correspond to what you've entered. As you can see, all the words of the assets are shown. And that concludes the demonstration. Upon completion of the iteration, we presented the client with a working model, or what we did at that point, and the client wished for a few changes. Visually, the text on the application was, when we're developing it, it's on the computer, and we didn't actually account for the side string onto the mobile platform. So the text was a little too small or a little too dull. She would also like, when we're selecting terms from the database, to keep those terms highlighted so the user is able to tell which terms are currently in their list. Functional features, she decided the quiz feature wasn't going to happen, and we're going to replace that with a random word, or we're going to replace that with a word of the day feature. She would also like the ability to save a list for the user so the user isn't forced to constantly repopulate the list every time they start the application. She also likes a image icon on the flashcard which the user is able to click and see an image of the word they're currently testing or looking at. The coding statistics for our program currently, we have 13 classes containing about 100 methods and about 1,900 lines of code. Most of those classes contain separate XML layout. We have about 20 XML layouts, which contain about 600 lines of code. And within our database helper class, there is about 10 unique SQL queries to the database. Our current progress, we would like to update the flashcard to the user's specifications, which include adding the ability to save their list, as well as add the flashcard feature to the iOS applications. For future iterations, once again, we are implementing the crossword, the ability to add a term to the database to make potentially the quizzing experience a little bit more unique for the user. Also the ability to save a word, and the settings feature, which again will toggle between English and Spanish language. And that concludes our presentation. Are there any questions?
You've clearly done quite a bit of work with the Android. Have you done any with the iOS yet?
We have been in development with the iOS. There is a steeper learning curve.
Yeah, I was going to ask you about that.
Yeah, exactly. And we're all familiar with Java, but we have been in development with the iOS, and we're confident that we can complete the flashcard version of iOS and the crossword version in the next iteration.
So as you guys know, I'm going to have to start working with the Objective-C by students. So how difficult has it been if you played with it also to learn?
We actually follow lectures from Stanford. They put the lecture on iTunes Use for free, and it's also like apply for the newest version. So pretty nice and with thorough tutorials.
Okay.
When you start adding more and more words in there, how are you going to be able to scroll to the bottom of your list quickly? Or to get to the M's or the J's?
Currently, there's a little slider on the side that you're able to just press and then drag it down, and it goes quickly and tells you which word or section you're in. We would like to also add an alphabet on the side that the user is able to click and go to that way.
Okay. How many words do you have in there right now?
Currently, there's about 1,000 words, and that doesn't include the Spanish versions of those.
I was a little unclear. So you can add stuff to this flashcard list, but how does the user take it off if we made a mistake?
Yeah, we.
We're gonna have to highlight the second word, but like if they click it again, it's gonna be unhacked. Yeah.
But that's not implemented.
Yeah, it's not.
It's not.
Okay. Is the database local or not?
It's local.
You guys said you were going to have it in English and Spanish. Is the whole interface going to be dual language, or is it just going to be the flashcards according to the names and stuff itself?
So that settings menu that you saw in there, it will bring up the ability to toggle from English language, and if they change to Spanish, it will bring up another layout that's specifically just for Spanish. So since the data entries that are Spanish are already in Spanish, all we need to do is, all we need to change in Spanish would be all our interfaces and like the instructions. And we have a few friends that are Hispanic. So.
Are you guys seeing any very similar UI design in your iOS platform?
Yeah, we're going to try keeping them similar as we can. There are a few differences, like Android has those buttons on the bottom, which we have to implement obviously on the iOS layout, but otherwise we're going to keep them as similar as possible.